Morning, y'all. Welcome to another fabulous episode of How Many Tabs Are Open on Mr. Johnson's Computer? 2, 4, 6, 8, 10, 11 on a Friday. We should close some tabs, Mr. Johnson. All right, so today we are looking at fractions. Yesterday we worked with decimals. So remember, decimals have a friend named fractions. They do the same stuff. They show pieces of a whole. All right. So we're gonna have pictures, and then also I'm gonna be doing the algorithms as well, and that way we have both side by side. All right. So you can use either of these today when you do your math quiz. All right, because your math quiz today is also going to be about fractions, and I will maybe preview that on this video. So first things first, let's get through the Google assignment. So we have an exercise where we're supposed to be adding 1/2 and 3/4. 1/2 and 3/4. All right. So one of the things that I want to do is I want to talk about how we would do this with the algorithm. Actually, let me just do this. Okay, 1/2 plus 3/4. All right. So we have the problem here in the numerical form, and then we have the problem down here in picture form. All right, so the first thing that we're going to do is we want to make these two denominators the same thing. All right, so we want to make sure that both of these fractions are cut into 4 pieces. All right, so here's what we're going to do. We are going to make the half into 4 pieces. All right, so you can see there's 3 out of 4 shaded over here. We have 1 out of 2 shaded over here. So we need to turn this half into fourths. So what we're going to do is if we cut each of those 2 pieces in half, now we have 4 pieces. 1, 2, 3, 4 pieces. 1, 2, 3, 4 pieces. So both of these now have a denominator of 4. All right. So basically what we've done is if we were doing this with the algorithm, we built a snowman next to the half because the half was the side that we needed to change. How do we turn a 2 into a 4? Can we turn a 2 into a 4 using multiplication? Yes, we can. So what we did is we multiplied by 2. All right, remember parentheses means multiplication. All right, so what I'm looking at right now is 1/2 plus 3/4, and I've drawn the snowman with 2 next to it. Over here, we cut 2 extra pieces, and that's what we're doing when we're multiplying by 2. All right, so what I'm going to do is on this right side, I'm going to rewrite this problem. So 2 times 1 is 2. 2 times 2 is 4. So now our denominators are the same. We can add those together, right? 2/4 plus 3/4 equals 5/4. If we count over here, we have 1, 2, 3, 4, 5. 5 pieces shaded, and we have everything cut into fourths. So our answer, I don't know why it left so many dots all about, but our answer is an improper fraction. They did not give us the opportunity to give them a mixed number, so our answer is 5/4. Do remember that 5/4 is equal to 1 and 1/4 because 4/4 is equal to 1 and 1/4 would be by itself. So if you squish those two things together, that'd be 1 and 1/4. So this is your simplified answer. This is usually what you're going to be answering. But to give the improper fraction, it's 5/4. All right. So that's the first one. 1/2 plus 3/4 equaled 5/4. We changed the 2 by building a snowman or by cutting 2 more pieces so that both fractions had 4 pieces. All right, let's check the next one. Okay, so we have 1/3 plus 3/5. All right, on this one, I can already tell it's going to be a little bit different. The reason why is I cannot turn a 3 into a 5 using multiplication. I cannot turn a 5 into a 3 using multiplication. So when we were talking about doing the algorithm and working with snowmen and everything, we know that this is going to be one of those problems where we have to build 2 snowmen because I can't just change one of the numbers into the other using multiplication. All right, So one of the things we can do is we can start making, we can make a factor chart for 3 and 5 to find out which number both of these can make. Some of y'all are thinking, I know my math facts. They both definitely make 15. And you are absolutely correct. So how can we turn both of our denominators into 15? And how can we cut these into 15 pieces? All right, so if we're cutting these into 15 pieces, first off, we have thirds, so we're going to have to cut this into 5 pieces. 2, 3, 4, 5. Okay, so we have 1, 2, 3, 4, 5 pieces that we just cut into, right? So that's the same as with the algorithm multiplying against the snowman of 5. All right, on this side, we have to cut the 5 into 3 pieces because 3 times 5 is 15. So we're going to cut, oops, we're going to cut, and then that makes 1, 2, 3 pieces, right? So what we did, oops, is we multiplied by 3 on this side. So now you can see the thirds have 15 pieces, the fifths have 15 pieces. We found equivalent fractions. So let me write these out. So over here, I'm going to move it over here. So 5 times 1 is 5. 5 times 3 is 15. Plus 1 times 3 is 3. 5 times 3 is 15. So we should have 8 fifteenths. Let's count. Let's count how many pieces we have. All right, so let me double check the math on that. 5. Oh, yeah, that should be fine. So we have 5 fifteenths over here. Oh, what did I do over here? This is what I did wrong. If you noticed, this was 3 fifteenths. That's what I did wrong. So sorry about that. That's probably confusing. Let me erase something real quick. Or we could just turn this into a 9. Okay, so what happened here is I wrote a 1. So that's something that can go wrong really easy. If you write the wrong number, it's going to be wrong. So I wrote 1. It was a 3. So I changed it to a 3. Now it looks right. So 3 times 3 is 9. 5 times 3 is 15. So 5 plus 9 is not 8. 5 plus 9 is 14. So, oh no. Okay, so we'll just do this real quick. 1/3 plus 3/5. Parentheses on both sides. We multiplied this side by 5. We multiplied this side by 3. So we got 5 fifteenths plus 9 fifteenths. 5 plus 9 is 14. So we have 14 fifteenths. And we can count those. Here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 fifteenths. All right, so whenever we write the answer, our answer will be 14. Of course it won't fit. And then 15. We'll stretch it out. All right, now it fits. 14 fifteenths. This cannot be simplified. Your numerator is 1 off from your denominator, so that cannot be simplified. So remember, if your numerator and your denominator are only 1 different, your numerator is 1 smaller than your denominator, it's simplified. All right, next one. So we have 1 and 1/2, and we're trying to subtract 1/2. All right, obviously, this one, if we're just thinking about it, if you had $1.50 and subtracted a $0.50, you would have $1, right? So this one, relatively easy to think about, all right, but let's actually do the problem. Okay, so what they want us to do is they want us to go ahead and cut this. Let's see, right there. This isn't even 1.5. That's 1 1/5. I don't know what they're doing here. If you see right here, this is 1 whole and then 1/5, and they're saying subtract 1/2, but up here it says 1 1/2. So we're gonna do both problems, but obviously we have the answer, y'all. 1 minus 1, 1 1/2 minus 1/2. If we took away a half from 1 1/2, we take away this from this. we are left with 1. I think what they wanted to do was 1 1/5. So I'll just do this on the side real quick, but you don't have to do this. Just your answer is 1. But you can't even put 1 right there. Yeah, you can. Just put 1 over 1. That's the same thing, right? Okay, so I think what they wanted to do is 1 1/5 minus 1/2. All right. And in that situation, what we would have to do is we take, we're going to basically make an improper fraction. So 1 times 5 is 5, plus 1 is 6. This is the same thing as 6/5. Remember, this is basically 5/5 plus 1/5. So we have 6/5 minus 1/2. Can I turn one of my denominators into the other using multiplication? Nope, I can't. So it's a 2 snowman problem. The number that both of these make, 2 times 5 is 10, so we're going to multiply this side by 5, this side by 2. So we get 12/10 minus 5/10, which gave us 7/10. I think that's the problem they wanted you to do, but this is not 1/5 like this is. So that's confusing. So on this one, basically, I would go with this answer. Just represent 1 as a fraction however you want. Remember, it can be 1 over 1, 2 over 2, 3 over 3, 4 over 4, 5 over 5, 6 over 6, 7 over 7. So it's not usually the way to show it, but I don't know how else we're going to show our answer on this one. So I'm going to call this 1 out of 1. Remember, anytime your numerator and your denominator are the same, it equals 1. So this can be 2 over 2, 3 over 3, 4 over 4, because all fractions are division. So 1 divided by 1 is 1, 2 divided by 2 is 2, 2 divided by 2 is 1, 3 divided by 3 is 1, 4 divided by 4 is 1. So remember, anytime you have the numerator and denominator the same, it's the same thing as 1 whole. So this page was funky. I'm sorry. Let's move on. All right, 3 1/3. Let's make sure they wrote the right thing. 1, 2, 3, and 1/3. Cool. And then here's 1 1/2. All right. I think we can do this one. It looks like we're subtracting. All right. So one of the things we can do, we can either make improper fractions. So I'm going to make improper fractions with the algorithm, and then we will use pictures to solve without making improper fractions. All right. So remember, to make an improper fraction, you take the whole number, multiply it times the denominator, and add the numerator. All right, so that's what we're going to do. 3 times 3 is 9, plus 1 is 10. So this would be 10/3. We keep the same denominator. All right, whole times denominator plus numerator, whole number 1 times denominator 2, that's 2, plus 1 is 3. So this is the same thing as 3/2. All right. So we're looking at 10/3 minus 3/2. Okay. Now, once again, we got to use our questions. Can I turn one of my denominators into the other denominator? Cannot. 3 does not turn into 2. 2 does not turn into 3. So I have to build 2 snowmen. All right. What number can both 2 and 3 make? 2 times 3 is 6. I don't know what's going on the side with my snowman. It's not drawing anymore. Maybe it'll draw like that. Okay. So we're going to multiply this side by 2. For some reason, I can't draw with my pen anymore, so this is going to be really fun. So there's 2, and then we're going to multiply this side by 3 because we need to make this denominator 6. All right? So we have 20 sixths, and then we need to subtract. Whoop. 3 times 3 is 9. 2 times 3 is 6. I'm going to subtract 9/6. All right. So 20 minus 9. 20 minus 9, y'all. Why won't it draw with my pen? 20 minus 9 is 11. So when we get back over here, our answer should be 11. And then our denominator should be 6. Once again, this is an improper fraction. If we wanted to make it a mixed number, right, it's 11 divided by 6. 6 goes into 11 one whole time. Oh, man. So 6 goes into 11 one whole time, right? So, and then there would be 5 pieces left over because 11 minus 6 is 5. So your mixed number would be 1 and 5/6. All right, so let's actually do this, this whole thing with the picture. All right, so what we're going to do is we are going to turn, we need to like make our fractional pieces have the same denominator. Our denominator was 6. So we have 3 pieces over here. So we're going to cut this in half. Like when we multiplied by 2, 10/3. We're multiplying the thirds by 2. So now we have 6ths over here. We want to also have 6ths over here. So this is a half. We need to cut this one into 3 pieces to make it into 6 pieces. And once again, with the snowman, if you look with the snowman, that's what we did on this side. We multiplied by 3. That's cutting into 3 pieces. All right. So we're looking over here. We have 6ths and 6ths. All right. Now, you can tell that right now I can't take 3/6 away from 2/6. So what I'm going to have to do is I'm also going to change one of these whole numbers into sixths as well. And that will allow me to start taking away. All right. So I'm going to use my tool to like draw X's to show what we're doing. All right. I need to take away one whole. So I'm going to take away one whole. And then I need to take away 3/6. And take away 3/6. All right. So now I have one whole. And I have 1, 2, 3, 4, 5, 6 pieces, right? Which is one whole and 5/6 pieces. So you can see over there, there's our answer in visual form: one whole, 1, 2, 3, 4, 5/6. We took away 1 and 3/6 from our 3 and 1/3. All right. So remember, whole times denominator plus numerator will help you get your improper fractions, or you can draw pictures. That works as well. When you're adding mixed numbers, just pull apart the whole numbers and the fractions and then squish them back together at the end. All right. The reason we could not do that is 1/3 is smaller than 1/2, so we had to do something extra. All right. Thanks for sticking around. Let's take a look at your quiz since y'all were sticking around, and I'll actually help you out. All right. So, what is the sum of 3/8 and 1/4? All right. What that means? Sum is addition. All right. So 3/8 plus 1/4. Can you turn one of your denominators into the other using multiplication? Can I turn an 8 into a 4 or a 4 into an 8? Yeah, you can turn a 4 into an 8. So we're going to build one snowman. We can turn 4 into 8 by multiplying by 2. All right. So as you can see right here, we're halfway there. I'll give you one more hint. All right. When we multiply this side together, we basically have 3/8 plus 2/8. All right. So there's a little help on that one. The next one. A park bench is located 16 3/4 feet due north of an elm tree. A fountain is located 9.5 feet due south of the same elm tree. What is the distance in feet between the park bench and the fountain? All right, so here is a tree, and it says the park bench. I don't know why I drew. The park bench is 16 3/4 feet away, and then there is a fountain that is 9.5 feet away. All right, so we're trying to figure out the distance between the two. So what we're going to do is we are going to take 16 3/4 and we are going to add 9 1/2. All right, so this is one of those situations where you can pull apart the whole numbers, 16 plus 9, and then add the fractions. So obviously you're going to need to find a common denominator over here. 2 can turn into 4, so we're going to build a snowman on this side of the 2. That'll help. All right, and then once you get your sum of 16 plus 9 and your answer to 3/4 plus 1/2, then you'll add them back together. So you're going to add the whole plus the fractional part. All right, and that will get you your answer. So 16 3/4 plus 9.5. Add the whole numbers, add the fractions, squish them back together. All right, question 3. Vanna used fraction strips to help her determine the difference between 5/6 and 1/4. All right, so if you want to, you can look for where the sixths are. Here's 1, 2, 3, 4, 5 sixths. And you can look for where the fourths are. Here's 1/4. So we're comparing 5/6 and 1/4. All right. If you want to cut up the fourths to where it's and the sixths to where you have the same number, you can do that, or you can use our handy dandy snowman. So can you turn 6 into 4 using multiplication, or can you turn 4 into 6 using multiplication? If not, we have to change them both. All right, so what can both of these numbers become? It looks like 12. So if you were going to mess around over here, oh, why do I keep doing that? Here's 5/6 minus 1/4. I'm sorry, and then we're gonna have to build 2 snowmen. All right. And so basically, what we can do over here is we can figure out the same thing. So 6 and 4 both make 12. So if I wanted to take the fourths and the sixths, and I can cut those into 12 pieces. Right? Well, this one looks a little weird. All right, and then over here, it said I have 5/6. Oh, I should have shaded the 5/6 first. There's 5 of the 6th, and then over here I had only like 1 of the 4ths shaded. So there's the comparison in visual format, right? You have this part, and you're taking it away from this part. So if you wanted to use the fraction strip, if we canceled these parts out, we'd have 1, 2, 3, 4, 5, 6, 7. And we'd have 7/12ths left over. So let's check this out. I think I just gave you the answer. So over here you have 20 24ths minus, oh, why did I do 24? We did 12 a second ago, didn't we? I don't even think I have an eraser tool. No, I do. Okay, sorry about that. We totally decided we wanted to change it to 12, and I was like, let's change it to 24. Okay, restart. All right, so we wanted to change it to 12, so 6 times 2 is 12. 4 times 3 is 12. So we have 10 12ths minus 3/12ths. All right, so that will also get you the answer. Okay, so we did it in pictures, and we did it with the algorithm. So just solve that one out, and you should find the answer. All right, final one. Read this following situation, decide if it's true or false. Kiana had 2 1/4 yards of fabric to make a pillow. She used 1 7/8 yards on the project. So basically what we're going to do is we're going to say 2 1/4. We're going to subtract 1 7/8. All right. 1/4 is smaller than 7/8, so I would use the whole times denominator plus numerator to get your improper fraction. All right. So 2 times 4 is 8 plus 1. That's 9/4. 1 times 8 is 8 plus 7 is 15. So there's a start. There's your improper fractions. 9/4 minus 15/8. You're going to have to change this denominator into an 8 in order to solve this problem. All right, so this is a 1 snowman problem. Just figure out what you have to put in the snowman, and that should get you to the end. All right, thanks for watching. Hope you have a great weekend. I hope that you're having success with all of this stuff and it's all coming back to you. And yeah, have a good day. Talk to your teachers if you need any help, and have a great weekend. Like and subscribe if you feel like it, and I'll see you later. Bye.